My only problem is mathematics. Okay.
Yeah, I know, it's part of the
Well, it is part of the U, but then we're at 1.
yeah, but I'm not putting in the derivative, I'm putting in u.
All right, guys, let's take a look at these first three. You cannot skip the u equals step. That's huge. It's going to help you out in two places. So in this problem, oh shoot, what did I leave off? The 6. The thing that's stuck is this guy. Now you do have the option to write this 6 times and multiply it out, but we'll see. No. Okay. So if I let u equal this, what's du? Now real quick, when I write du dx, right? All we're doing now is just multiplying that sucker up over here. What's the derivative of this? Do I have this much? Yes. So I'm just missing a number. That's beautiful. I can handle that. If I'm missing an x something, then it can't. Then I did something wrong. So if I want to put a 15 in here, I better put a 1/15 out there. I got a few places where I like the whole Indiana Jones thing. Right? If I put the bag of sand, I better take the gold statue away, and he just didn't quite. It was like 15 and 1/14. He didn't quite balance it out. The rock was down. If you've never seen Indiana Jones, you scare me a little bit. So now I can write this. And then look, people always get confused about why that's still there, but 15 times x to the 4 dx is what? Du. So that's du. Of course the 1/15 is still there. It didn't get sucked into anything. Poor little dude. What's this got to be written as now? U to the. And what's the integral of u to the 6th? So, and what was u? Oh shit. And 15 times 7. Sure.
How do you know to put the plus c unless there was a
No. You don't have to put the plus c if it's a definite interval. Why? Because then it would cancel. Here, there's just one answer. There's no difference between two things. All right. Now over there, I see an x cubed and an x squared. The derivative of this is related to this. So it kind of tells me, plus, this is stuck inside of the square root. You would almost never let u equal the square root of the whole thing. Oh my God, that derivative would be gross. And it's not in there. So if I let u equal x cubed plus 1, what's du? Do I have everything I need? I have x squared dx. I'm missing a 3, which tells me good stuff. It tells me, okay, I can do that. I can balance the constant out. So now 3x squared dx is du. 1/3 is sitting out there. And now I got a square root of u. Okay. And then what's the integral of u to the 1/2? the 3/2. Yeah, times the reciprocal, because you divide by the new power, so if it's fractional, you multiply the reciprocal. I always have somebody ask me, why isn't it 1/3 C? Sure, it is. It's just a constant. So any constant multiple of a constant is a constant. Oh, okay. So I just get 2/9. What was U? See, this is the other place that helps you, right? If you write it, you'll see what the hell it was. To the 3/2. How? I didn't check any of these that we've done. You just take the derivative, which is always easier than the integral was. And then over there are some freaky integrals where this is not true, but it's almost always true that you let u equal the thing that's inside something else. So what's inside something else? Square root of x, right? So what's du going to be? So this is x to the 1/2.
1/2 of x to the negative 1/2.
Do I have that? I've got x to the negative 1/2 dx. What am I missing? So I need a 1/2 to get in there. So outside I better put a 2. Same idea, just the reverse of what we've seen before. Right? So overall, what did I just multiply by? 1. I just multiplied by 1. Which is on the surface, you'd be like, wow. But it totally changes the inside into a form. It doesn't totally change it, but I can go forward now. I got what I need for my du. So I get 2 integral. All this becomes du. And this is the cosine of u. Oh my God, that's awesome. Integral cosine is sine, and u was square root of x. Okay, maybe. Let me go over there. Well, let's see. Yeah, maybe I'll do. Let me do that bonus real quick so I can erase it. My hint on this was factor. I know a lot of you guys didn't try this out yet, but this is not an example of something I would just give you out of the blue. This is completely freaky shit. How do you factor this? What would come out? Yeah, x to this 2, right? You always take out the smaller power. So how do I factor the bottom? I take out an x to the 1/3, and what's left? So what looks to be a good candidate for u? This stuff in here. If u is x to the 2/3 plus 1, what's du? 2/3. X to the negative 1/3. Do I have x to the negative 1/3 dx? Totally. So what am I missing? 2/3. So on the outside I better put. Okay. Now, from here to here, I really doubt any of you would have thought about it, which is not a problem. A lot of math is show me what I'm allowed to do. How much flexibility is there in these kind of problems? So here's something you would never think of, and now you might think of it later because you've seen it once, right? So let's see. This will be 3/2 integral. This is du, right? 2/3 x to the negative 1/3 dx, and then I'm left with 1 over u, which is 3/2 natural log of, what was u? Whoa, shit. Poor little 3/2. Weird? Yeah. That's why I wouldn't give it to you like out of nowhere. But I want to at least show some people. Okay, I'm going to take that away now. Or maybe I'll take those away. Sell some more board space. See, there's a really obvious inside. It's like inside. What is that? Natural log x, yeah. I'm not saying this will work every time, but a good place to start is with the thing that's in the innermost. What's du? Is that in there? Yes, it's exactly in there. Don't need a constant or anything. It's awesome. Now, if you want to change the limits, if x is e to the fourth, u would be natural log of e to the fourth, which is 4. If x is e, u is natural log of e, which is 1. I like it. So what's this look like now? It's going to be integral from 1 to 4. 1 over x dx is du. And then I get 1 over the square root, so let's just write that as u to the negative 1/2. So then I get, what is the integral of u to the negative 1/2? Yeah, it's u to the 1/2, then you multiply the reciprocal, I like it. I don't have to put plus c, right? Because it's got definite, it's a definite interval, it's got endpoints. Why don't I bring this back to x? Because I made the limits in terms of what u does, so I don't, it's not that I just don't need to, it's that if I did, I'd be wrong. This is not what x does, this is what u does. So this would be 2, square root of 4 is 2, minus 2 times the square root of 1 is 1. So I get, is everybody cool with that? So I get 2, Jeff. You can do it. I like it. Oh, I see. Yeah, that was you're really wrong. All right, and then let's see. One more, right? Yeah. This one I think was everybody's favorite. So many things about this problem I love. You got this trig identity on the top. Whenever the angles don't match, if you can make them match through a trig identity, you almost always do that first. If the angles match, you can do more stuff with it. I'll be honest, on this problem, it doesn't matter if you let u equal that or u equal the whole thing. Either way, it's going to be the same derivative, right? Because the constant piece isn't going to contribute anything. In general, I let u be the most it can be. So if u is this, what's du? 2 cosine x times negative sine x, I like it. Do I have that?
Yes, sir.
Yes, just missing a negative, right? I can always balance out constants. So this becomes, oh, let's see, let's change the limits. If x is pi over 3, u would be, what's cosine of pi over 3? That's the bigger angle is further away from x. Cosine likes x, so cosine is going to be scared. It's going to be tiny. 1/2. Okay. That's how I keep it in my head. And 1/2 squared is 1/4. And 1/4 plus 1 is. And if x is 0, what's cosine of 0? 1. And 1 plus 1 is 2. That's amazing. Yes?
So what is the one outside of the cosine?
If I meant this, I would have written this. I really want you to understand. If you put parentheses in, you more than likely are changing the problem, right? This is what parentheses do. They tell you, in this case, what's inside cosine. Since there are no parentheses, then the only thing inside cosine is the x. You guys get that? Is that cool? All right. This becomes a totally different. See how the angles are completely different now. They would never match up, so that would be basically impossible for us to do. That would have been a little bit evil. So now I got negative integral. What's 0 become? 2. And what did pi over 3 become? Do you see how 2 is bigger than 5/4? So it doesn't have to go small to big. It has to go from whatever to whatever the shit it was. Right? Don't just do that and then put them in the order. No, that one to this, that one to this. You can't. You can if you make that the opposite sign, yeah. Real quick little side note. Integral a to b equals negative integral of b to a. This would be big ass f of b minus big s of a. F of a. This would be big ass f of a minus big ass f of b, which is the opposite of that. So that, of course, that makes sense. So yeah, you lose the negative and change those if you think about it. What do I have inside now? I got, this whole thing is du, and then I got 1 over u, which is our little what? Yep. And what was u? Oh wait, I don't want to do that. So this is my problem. I so automatically do that because I like the other method, the little parenthesis method. So just let me know if I do that. I don't want to bring it back away from you, do I? Because I've changed these to be all about you. So then you get negative natural log of 5/4 plus a natural log of 2. I don't need the absolute values, do I? Because those are positive values, right? Which I prefer to a decimal answer, to be honest. That's the exact answer. Any decimal you give me is not going to be the right answer. Damn it. Is that alright, you guys? Now, U sub takes some getting used to, but I saw a lot of light bulbs going off today, which is nice. You start to realize how beautiful U sub is. I know I say that a lot about everything. What was the last thing I want to talk about? Well, we get into this next time. We're going to get into chapter 6 next time. Start with the integral by itself is between the x-axis and the function. We're going to get into a situation where I'm like, okay, here's one function, here's another function. What's the area between those functions? So the floor isn't nice, isn't the x-axis, the floor is whatever the shit the other function is. Which isn't anywhere near as hard as it might sound to you right now. Yes, it is. The hard part is finding these for a lot of people, because that's algebra, and we seem to always forget poor little algebra. Even though it's the backbone of every damn thing we do. Alright, that's enough for today.